Alright guys, I'm back with another example video here. I'm going to show you how to factor by grouping. This works when you have a polynomial that has 4 terms in it. For example, we have x to the third plus 7x squared plus 2x plus 14. Usually the idea here will be that you'll group the first two together and you'll group the last two together. That's not always the case, but it's a good place to start for a grouping problem. So here we have these two grouped together and these two grouped together. And what we're going to do is we're going to try to pull the GCF out of each term. So we have x squared is the GCF here, which would leave an x plus 7. On this side, we can pull out a positive 2, which would also leave an x plus 7. And at this step, you'll know whether or not you did it right, because if you don't have the same thing in both sets of parentheses, you probably screwed something up. So you might want to go back and try to group the problem differently, or check just to make sure that you pulled out the GCF correctly. Alright, so next what we want to do is, well, we have x squared times x plus 7. That's one of our terms. We have plus 2 times x plus 7. That's our second term. So we have two terms here. They both have an x plus 7. So the last step here is to pull out a GCF. They both have that x plus 7. If we factor that out of both terms, well, here it leaves an x squared, and here it leaves a positive 2. So your final answer will be x plus 7 times x squared plus 2. Okay, let's look at another one. Here, let's start off factoring or grouping the first two and the last two together. The first two share a 6 and an x. If I factor that out, I have x minus 4. The second two share a 2 and a y. If I factor that out, I have negative x plus 4. So notice here that the way we've done this, I have an x minus 4 here and a negative x plus 4 here. And those look remarkably close, but they're not the same thing. To fix it, what we need to do is we need to factor a negative out of either this side or this side. Usually it's done on this side. So I'm going to make this a negative 2y, which will change that to a positive x, and change this to a negative 4. So all I'm doing there is pulling out a negative 1 from both of these and sticking it out here. Okay, so now I have x minus 4 and x minus 4. So I can factor that out of my two terms here, and I'll have 6x minus 2y left over. Notice that 6 and 2 both share a factor. They both have 2 in them, so I can factor out a 2. My final answer would be 2 times x minus 4 times 3x minus y. Again, it's a good idea to check yourself just to make sure you didn't screw something up. So run through it real quick and make sure that this multiplies together to be what you started with. If you're working this out as a novice, notice that if you end up with a GCF in the end, that probably means you had a GCF up front to begin with. So notice looking back that all of these things had a 2 that I could have pulled out had I seen it then. But if you don't recognize your GCF at first, well, you can usually catch it later as long as you're being mindful of what numbers you're writing down. Okay, so looking at the next example, let's see what happens if we group the first two and last two. So here, notice that the first two, they don't share a GCF, but they are a difference of 2 squares. So we would factor as y minus 5 and y plus 5. And on the other end, well, these do have a GCF. They have an x. And usually to switch the sign, you'll make it a negative x. So if I factor that out, I have an x minus 10 left over. And notice that I have an x minus 10 here, but I don't have any x minus 10s over here. What that means is I probably didn't group this correctly. And sometimes you'll run into a problem where the first thing you try doesn't always work out. What that means is that, well, you scrap that idea and you go back and try something else. So notice that what we can do is we can rearrange these numbers up here and make it y squared minus x squared plus 10x minus 25. Okay, and then the next thing I'm going to do here is I want to factor a negative out of these 3. So really I'm going to group this, instead of 2 and 2, I'm going to group it 1 term and 3 terms. So if I factor a negative out of that side, well, I'll have x squared minus 10x plus 25 left over. Notice that this is a perfect square trinomial. In other words, this is a perfect square, this is a perfect square, and the middle term is 2 times the first root times the last root. So what this means is that this will factor as x minus 5 times x minus 5. If you want to do guess and check on this, it'll work perfectly fine. However, recognizing that it's a perfect square trinomial will generally save you time in the long run. So if that's the case, then I could rewrite this problem as y squared minus x minus 5 squared. And instead of the normal grouping approach, we end up with a difference of perfect squares. And that will factor as y minus x minus 5 and y plus x minus 5. Okay, so it's just a difference of squares problem, and factors like this. So this is where we'd stop. So this is a really good review problem. So it ties in factoring by guess and check, and also factoring by grouping, and also factoring by difference of squares. So it's got 3 different methods there, all in one problem. Okay, kind of the same idea down here. Start off by trying to think about how you want to group the problem. Well, I noticed that just like the last one, up here I had a y squared and then everything else had either x's or numbers in it. Well, here I have an x squared and everything else has either y's or numbers in it. So I probably want to do the same idea again, grouping these last 3 together. So there, if I do that, I can factor out a negative 1, which will leave y squared plus 4y plus 4, which again is a difference of, a perfect square trinomial. It factors as y plus 2 quantity squared. And then just like the last one, I have a difference of 2 perfect squares. So that's x minus y plus 2 times x plus y plus 2. And that's where you'd leave it. That's as far as that one will go. Okay. So recognizing how to solve one of these problems takes a lot of practice. I have a degree in mathematics, so I've seen several of these problems throughout the years. However, if this is your first time, don't be ashamed if you make a mistake the first time and the first thing you do doesn't work out, kind of like we did here. It's more than okay if it takes you a couple of tries to start to recognize things. And the more of these problems that you try on your own, the better you'll get at recognizing patterns and looking for things and realizing how different polynomials will factor the first try. All right. So looking down here at this last one, we have 6 terms here, which means that, well, maybe, I don't know, maybe I can group the first 2 and the middle 2 and the last 2. Or maybe I want to group the first 3 and the last 3. And really, until you try it and jump into it, you don't really know which way is the best. But looking at the numbers, I have x to the third, x squared, and x. And I have numbers that seem to share a common factor there. Same thing on the end here. 4, 8, and 60 all share a factor, and all 3 of these terms have a y in it. So I'm thinking that I'm going to group the first 3 together and the last 3 together by looking at the numbers that I see in them. So here I have a GCF of 3x. If I factor that out, that will leave x squared plus 2x minus 15. On this side, I'm going to pull out the negative just to be on the safe side, because I don't like the way that the signs are lined up. Here they're positive, positive, negative. Here they're negative, negative, positive. So pulling out a negative, and I'm also pulling out a 4y. If I do that, I'll have x squared plus 2x minus 15 left over. So then notice that both of these terms here, this one and this one, they both have that x squared plus 2x minus 15. And if I factor that out, I'll have a 3x minus 4 left over. And hopefully, if you've watched the other videos, this should look familiar to you. This is this is a guess and check problem. It factors as x times x and negative 3 plus 5, because 5x and negative 3x would give you 2 in the middle. Alright, so there's your answer on that one. X minus 3, x plus 5, 3x minus 4, y. I want to say there was one other problem that I wanted to show you as an example. Yes, this one. Right, so coming back up here real quick, there's one more that I want to do, and then I'll let you go. So just another unique approach to solving these problems. We looked at some that looked kind of like this, where they factored as 3 and 1. This one, though, is unique. We want to first rearrange the terms, like so. And notice that if I group these 2 and 2, now that they're arranged this way, well, this is a difference of 2 squares. It will factor as x minus y times x plus y. And on this side, I can pull out a negative 1, and that would leave x plus y. And notice that both of these now have the x plus y. And if I factor that out, I'll have x minus y on the left side and minus 1 on the right side. So there would be my final answer. Okay, so there's a lot of really unique problems with factoring by grouping. It's really not one of my favorite types of factoring methods, but it is pretty cool. Yeah, so just don't be afraid to try different things. If it doesn't work out the first time, well, try something else. See if that works. If you've tried everything you can think of and you can't get it to factor the way it's supposed to, the answer could be prime. Again, you don't typically see a lot of those because, again, they're really cruel to give you that. But you can usually recognize a prime one up front. Like, let's say you had 4a plus 5c minus 8b plus 17d. If you're looking at these and you can't group them together such that each group would share something, like here you have A and C and here you have B and D, those will never be the same. So this, you can't do anything with that. So that one would be an example of one that's prime. Right. So if you have any questions, feel free to leave a comment below. I'd be happy to make a follow-up video if I need to. Otherwise, good luck.